Welcome everybody to Chapter 5, Section 3, Side Angle Side Theorem. If you notice, my audio is a little different. You're my first video with a microphone. I hope it's better. There are some notes to take for side angle side, but as I kind of introduced to you at the beginning of the chapter, it's really about what you see. So I'm going to help you with that. Now, there's a lot of proofs here, and we didn't really focus on proofs. So we are going to work on those together, and I think you'll be okay with it. However, I want you to get the right idea. Now, obviously, you should have your textbook. You should have your notebook. You might want to pause the video and go grab your journal, because I'm going to use some of the examples in the journal as well. And you might want multiple colors for this, since it's kind of hard to take notes with words, except for the core concept. The rest of it is going to be very visual. All right. So hopefully you paused and got what you needed. Turn your textbook to page 246 and go ahead and copy down Theorem 5.5 at the top while I switch my document cam on. So Theorem 5.5 is the side angle side theorem. And basically, if we can show that two triangles have corresponding side angle sides that are congruent in that order, side, angle, side. So there's a side, there's an angle, and then there's a side next to it. Or there's two sides with an angle in between, another way of looking at it. If we can show that one triangle has the same measurements as another triangle, we can say definitively those two triangles are congruent, the whole thing, just by knowing that two adjacent sides with their included angle, that's a key vocab word, included angle, are congruent. All right, I already copied down, so there's plenty of examples. You might want to go to the Big Ideas textbook and watch some of those videos for extra clarification. I'm going to be honest. So from these examples, and they kind of go over proofs as well. Again, we'll get to that. It's going to be in class, though, not on a video. On page 247, I copied down the figure that goes with numbers 1 and 2. So you're going to pause the video now. You're going to copy it down. Okay. So hopefully now you paused and you copied it down. So we're not going to prove with the technical structure, the two-column proof, right now in this video. I'm going to get you there soon. Let's prove by finding, keep in mind, we want, figure not drawn to scale, but we want a side, an angle, and a side to be in one triangle, to be congruent to another side, angle, side of another triangle. I'm just trying to help you visualize right now. Okay, so we need to prove, I'm going to get a highlighter out, triangle SVR is congruent to UVR. Oh, wait, but first, the directions for page 247, numbers 1 and 2, tell us that this is a square. So we know that ABCD is a square, knowing that AB is congruent to BC, is congruent to CD, is congruent to AD or DA. They're also telling us that R, S, T, and U are the midpoints of its respective sides. R, S, T, and U are the midpoints. So here, congruent, 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 right? This is in the middle of this. AB is congruent to BC. R is in the middle of AB. These two sides are congruent, but they're also congruent to here, 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 here. We know that RT is perpendicular to SU. RT is perpendicular to SU. All right, so we kind of also know this is a right angle, this is a right angle. I'm trying to do it at different lengths so you see that they're all right angles, they're all 90 degrees. Finally, SV is congruent to VU. Now, they don't tell us that SV is also congruent to CT or BR, and VU is congruent to TD and AR. Let's see if it becomes important. Okay, we're wandering down a path and we're not really sure where it's going to go. It might be important that they're all congruent. It might not be. Okay, so this is from the directions. Again, if you didn't draw it out, you probably should have paused and rewind, start drawing. Now they want us for number 1 to prove that triangle SVR is congruent to triangle UVR. Okay, so these two triangles, I hope it's okay that I'm using orange for both triangles. We don't know they're congruent yet. All right, we need to definitively say that we can pair up 2 sides, 2 angles, and 2 sides from each triangle to give it SAS. So again, not in a 2-column proof. We're looking for SAS. All right. First thing I see is that they gave us that SV is congruent to, I want to say it in the same way that they did, VU. All right. So there's our sides. We matched up a pair of sides from each triangle. Angle. Well, we know that these two are perpendicular lines, which means that angle SVR is equal to 90 degrees. Angle UVR is equal to 90 degrees. Thereby, these two angles are congruent with each other because of the transitive property. But I hope that's obvious. If this is equal to 90, this is equal to 90, these two are equal to each other. All right, we proved 2 corresponding sides, 2 corresponding angles. If you're having trouble following, I know my orange pen doesn't come out, but basically side, angle, side, angle. We know those angles are 90 degrees in my wonderful Picasso that I made. Finally, so side, angle, I need to prove the next side over in order. Side, angle, this side, angle, this side. So can I prove the next side? Well, we can definitively say that VR is congruent to itself. It's itself, right? It's the reflexive property. And then, therefore, I now have side, angle, side. Side, angle, side. We must now say, we can say now, definitively, SVR, triangle SVR, is congruent to triangle UVR. Woohoo! Okay. Might got a little lost. You always can rewind, but let's reinforce what we just learned, because now they're asking us to show, prove without a doubt. We're not assuming, we're not making it up, we're not guessing, that triangle BSR, so in this direction, is congruent to triangle DUT. Okay. This is obviously just SAS. So let's actually get out our Greek. Okay. All right, now I have to move down a little bit. So notice what I did right now, SAS. Oh, let me get a darker green. All right, we need side, angle, side. Well, right now I see 2 sides that are congruent to each other. These 2 sides and these 2 sides, 2 pairs of sides. Pair, pair. Now we just got to get the inclusive angle. Remember, that's a key vocab word, especially to practice on your big ideas homework. The inclusive angle. But wait, don't we know that ABCD is a square? So then we do know this. So let's see what we can say. We can say that side BR is congruent to side, let's see, they said BSR. Remember I said order mattered, so BSR, I said BR, so side DT. That's where, see how it's BR, it's got to be DT. They're congruent, right? And that was given. They gave us that everything is a midpoint, or R, S, T, and U are midpoints of the respective sides, and all the whole big shape ABCD is a square. So all those sides are equal. If you split those sides in half evenly, then every half is equal to itself. That was a given. Now, angle, well, we said the angle in between. So angle angle SBR is congruent to, this was a given, is congruent to, what we say, SBR, S pairs up with U. So U, S pairs up with U, U dt, because D is in the middle. D is in the middle. Boom, 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 boom. And that's because it's a square, right? All the angles are 90 degrees on the edges of squares, the corners of squares. And then finally, so we said BR, now we need to say BS. So side BS is going to be congruent to side DU because, well, that was also given in the directions. Well, let me scroll down. Square. So we found a pair of corresponding sides that are congruent, BR and DT. Remember I told you ordered mattered. So I randomly chose to call it BR. I had to figure out now, how do I call it in this triangle? Well, the B is in front, so D, and R is in the back, T is in the back, DT. SBR is congruent to UDT. Well, that's the definition of square. They're both 90-degree angles. And finally, BS is congruent, side BS is congruent to side DU, given as well. All right? Okay. Hopefully, this started a certain mindset for you. That's the goal, right? A certain mindset. We're going to work on developing 2-column proofs later, as I said, but if you just write out SAS and make sure each line has the correct pair of corresponding congruent sides, correct pair of angles, correct pair of corresponding congruent sides, then you have the right idea of proving, knowing with absolute certainty, these two triangles are congruent. These two triangles are congruent to each other. These two triangles are congruent to each other. Okay? All right. Let's see if we can apply that knowledge, because really practice and seeing it, visualizing. Remember, the goal is by the end of the chapter that we have a very strong intuition about what's right. Now, of course, we have to back it up with proof when we need to prove without a doubt something, okay? But we can have a good intuition. We can have a good understanding of the fundamentals here. Okay, this is your journal, page 136. Feel free to write along with me. Now, we're going to get to the 2-column proof later. Don't worry, this is going to be a class time thing. But let's now fill out, because we can draw on it as the directions tell us. All right. So they gave us the figure. They tell us that BD is perpendicular to AC. All right. So now we know this, which they gave us. Now we know this. They tell us that AD is congruent to CD. Boom and boom. These two sides. Notice the red. Sorry that it's a little messy now. CD, right? I like to write over it. I like to write on these things. Now we need to prove triangle ABD. ABD is congruent with CBD. Don't be afraid to use your fingers to trace it. All right, so leave some space. We can fill in the rest later. Side, angle, side. All right, well, first of all, they already give us a pair of corresponding sides in these two triangles. We know that AD is congruent to CD because it's given. We know that this angle, well, yeah, no, I don't apologize. BD is congruent to AC. So now we know that angle ADB is congruent to CDB. There's a lot of reasons. CDB. CDB. Remember, order matters. A from the outside into D. ADB. C from the outside into D. CDB. Angle ADB is congruent to CDB. Now, it's not technically given, but it's because, perpendicular angles are congruent. Don't worry about what you write. We understand that if two angles are 90 degrees, they're equal to each other. We talked about it as a transitive property in previous example. So finally, now, what is the next side? So here you need to use your brain. this flows, side, angle, side. Take your finger, side, angle. You're not skipping to this side. Side, angle, side. This is the next side. Can we prove that side BD is congruent with itself? Because if we know that side BD on this side of the triangle is congruent with side BD on this side of the triangle, then we have SAS, or rather, how I want to do it, SAS. Match them up, okay? Well, duh. BD has to be congruent with itself because of the reflexive property. All right, and there you go. We have a statement without a doubt confirming that we have corresponding sides, corresponding angles, and then the next corresponding sides are congruent. Boom, we prove that these two triangles are congruent. Good job. All right, let's do another one. Fill it out as we go. I know they tell us for us. All right, JN is congruent with MN. NK is congruent with NL. Oh, this is important. I'm going to take my highlighter. We need to prove that triangle JNK is congruent with MNL. All right, that's important because it means we have to look at the appropriate angle. So, SAS. Okay. All right, well, wait. Side, 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 side. What's missing in SAS, or side, angle, side, side, side? Okay, so we have these two sides. They give us that JN is congruent to MN. Ooh, and we can skip down here. They give us that NK is congruent to NL. So I guess it's really just the angle. What angle, side, angle, side? We have to get this angle right here. Side, angle, side. It has to be this angle right here. So angle JNK is congruent to angle MNL. Remember, order matters. Why? Well, one word. They're vertical. They gave us the two sides. That was really nice of them. And we just had to fill in the angle. Keep in mind, why is it this angle that I went to? Why wasn't it this angle or this angle or these two angles in this right over here? Why? Because they gave us two sides and it has to be the included angle. What is in between included? What is in between the two? Okay? All right. That was a long video with a lot of notes and a lot of drawing. Thank you for being with me. We obviously are going to have some practice. Starts with vocab with that included, the angle in between. Included, the angle in between. So check the assignment online and I'll see you in class.